Thank you for coming. So thank you for joining the meeting. Today we're super excited about talking about these new features. The pool mode allows you to use Sveltos across environment where there are firewalls, there are NATs, there are all kind of different ways that prevent your management cluster to access directly the API on the managed cluster. So yeah, super excited to see this feature. A long time coming. I know Gianluca was just telling me that he hasn't slept in the last month or so, working overnight, developing this feature. So I can't wait to see how it works and what it's allowing us to do. And then, like always, if you have any questions, I'm going to be monitoring the chat. So feel free to ask anything in chat. And then either I answer in chat or I ask Gianluca to answer, or if people here in the call knows the answer, feel free to answer. You might know even more than I do about Sveltos. And yeah, with that, I think people in the meeting are all familiar with where to find information about Sveltos, how to download it, how to get started. They know about the Slack channel, the website, the AI bot for simple Q&A. And with that, I think I can pass the mic to Gianluca for this intro on this new awesome feature that is coming up really, really soon.
Hey, thank you. Thanks, Simone. Thanks, everybody. I cannot see your face because I have like the presentation mode, but thank you. I think this slide summarizes what the goal is: to manage any cluster anywhere. It doesn't matter where, what is in front of the cluster. So a little bit just about me. Gianluca Mardente. I started working on Sveltos 3 years back. Actually, this week is Sveltos 3. I started because I needed a tool like Sveltos because we were working on a project managing multiple cluster, and everybody was reinventing the wheel of I need to deploy automatically an Helm chart or a YAML to this cluster with this label or to those clusters with this other label. So I started with Sveltos. Here are a few links on my GitHub profile and my LinkedIn profile. And I'll just move straight to the problem definition and what this feature is about. And I also have some slides, but I also have a live demo, and crossing fingers that will work because there is no official release with this feature yet. So but hopefully it's going to work. But the demo is also on the list in this webinar. So the idea of Sveltos so far is that Sveltos runs in a management cluster. And from this management cluster, you can manage add-ons and application in any other cluster. It has built-in support for cluster API. So if cluster API is also running in the management cluster and you're using cluster API to create clusters on demand, Sveltos automatically detects those clusters and there is nothing else that you have to do. You just label your cluster API cluster and Sveltos will be able to deploy application add-ons based on the labels on a given cluster. But any other cluster can be registered with Sveltos. So you can have EKS, GKE, Civo, Azure, Ethernet cluster. Any type of cluster can be registered with Sveltos. The only requirement that Sveltos had so far is that from the management cluster, Sveltos required to be able to access the API server of each of those managed clusters. So that was the requirement today. What that means is that if my cluster is in a private network or behind firewalls, Sveltos, before this new feature, could not manage that type of cluster. Or if I have a cluster whose API server is using a private IP address, the API server is not reachable from the management cluster. Sveltos was not able to manage the cluster so far. Again, this was before this feature. So the idea of this feature is this one, that Sveltos keeps running in the management cluster. And again, you may have any type of clusters which is directly reachable from the management cluster, can be managed the way it is managed today. But what if I have a cluster which is behind firewall? Again, in this mode, clearly the management cluster cannot push anything to the managed cluster because there is no, from the management cluster, we cannot access the API server on any of those clusters behind the firewall. So the idea of pool mode is that when registering a cluster which is in pool mode, an agent will be deployed by the user in those clusters here. And then what this agent will do, it will come to the management cluster and will say, what is the configuration that I need to apply? And so the agent will then apply the configuration to this cluster. So we are reversing the problem here. So far, the problem was from the management cluster, we need to be able to access the API server of the managed clusters. In this case, if you have a clusters that are behind the firewalls, like in this example, just make the API server of the management cluster reachable from those clusters here, and an agent with very strict permissions will come and fetch the configuration from the management cluster, and then it applies here directly. Again, you don't have to worry about like callbacks, because as part of, we'll see how to register a cluster in pool mode. But in pool mode, in the management cluster, we give this agent here very strict permission. Essentially, it can only take the configuration which belongs to it that he has to deploy. It cannot see any other cluster. It cannot take anything else. It cannot do anything else in the management cluster. If there are questions, like at any point of time, feel free to interrupt me. I'm happy to take questions, like at any point of time, or clarify if something is unclear. So this is a slide that explains how Sveltos deploys in push mode, and then we'll see like the same slide in pull mode. So in push mode, if you're familiar with Sveltos, you know that you create a cluster profile, and the cluster profile is a section, which is the cluster selector. And a cluster selector is just a pure Kubernetes label selector. And so anytime Sveltos finds a cluster that match this label selector, so a cluster that has label MV-FE, in this case, Sveltos will deploy whatever it's defined in this section here. In this section, we have just one Helm chart, but you can specify like more Helm charts, so you can even specify YAML, JSON, anything, and Sveltos will deploy. So we apply this cluster profile to the management cluster. As you know, for every cluster which is registered with Sveltos, there is an instance in the management cluster representing the cluster, and that's where you add the label. So if we add the label environment verification on this cluster here, what is going to happen is that Sveltos detects that this cluster is a match, because the labels environment verification is a match for this cluster selector, takes the content that in this case is this kernel chart, and deploys to this cluster. And if the same label gets applied to the other cluster, same process repeats. Sveltos automatically detects that this cluster is a match for this cluster profile, takes the Helm charts or YAML that needs to be deployed. In this case, it's just like the kernel charts, and deploy it. And if you remove the label from a cluster, the default Sveltos behavior is to say this cluster is not a match for this cluster profile anymore. So whatever was deployed because of this cluster profile will be undeployed from this cluster. This is the default behavior, but there is a knob that allows to override this behavior and say, if a cluster stops being a match, leave whatever you deployed on that cluster, leave it there. Because that might be the case where you are preparing a cluster that you want to give to somebody else. So you want to prepare the cluster and put all the right set of add-ons and applications, but then because you are essentially handing over the cluster to somebody else, you want to leave those things, you want to leave whatever you deployed on the cluster, and then somebody else will take it over and decide what to do. Now, if we are in pool mode, what happens is that the way we specify what needs to be deployed remains exactly the same. So we always create a cluster profile. We always specify a cluster selector in the cluster profile, selecting what are the clusters which are a match for this cluster. And we always specify what are the list of application add-ons that we want to deploy. But when we register a cluster that is in full mode, and again, we'll see in the live demo to do that, one of the things that we have to do as part of this registration is deploy this Sveltos agent on each of the clusters that are in full mode. Clearly, again, because Sveltos cannot reach the API server of this cluster, Sveltos cannot deploy this agent. That's why this agent needs to be manually deployed by the user in any cluster which is in full mode. Now, once this agent has been deployed, as soon as we apply the cluster profile and put a label on the cluster, the exact same process that we described before, it happens. Sveltos detects that this cluster is a match, takes whatever needs to be deployed, and prepares the configuration and prepares a configuration for the agent saying, you have to deploy Caverno in chart. And the agent comes, picks whatever needs to be deployed, Caverno in this case, and deploys it. So in this case, it's not Sveltos pushing and deploy Caverno on this cluster here. What Sveltos does, it detects that this cluster is a match. He knows that he has to deploy Caverno, and so he prepares some configuration in the management cluster for this agent, telling this agent, this is what you need to deploy. So the agent can come, take the configuration, and deploy it. And the same happens on the other side. We put this label. Again, Sveltos prepares detects that this cluster is a match, and prepares the configuration that this agent needs to deploy on this cluster. And then this agent can come, pick the configuration, and push it. And as soon as this cluster stops being a match, Sveltos prepares a configuration that tells these agents, you have to withdraw Caverno. And so this agent here will go and withdraw Caverno. And again, you can, as described before, you can override this behavior. But the main point is that because we cannot reach the API server of this workload cluster, Sveltos simply prepares the configuration that the agent needs to deploy. And the agent as a watcher, so he knows when there is something new, some action that he has to take. And so as soon as Sveltos components, the management cluster, prepares something that the agent needs to do, an action the agent needs to take, the agent detects that there is something he has to do, and he does it. And in this case, was deploying Caverno. Of course, we can have a mixed mode where we can have some cluster which are in push mode and some cluster which are in pull mode. Because the way we describe what needs to be deployed, it's exactly the same. We create a cluster profile, and once we register this cluster, this agent gets deployed. There is no agent here because this is in push mode. So with respect to deploy add-ons and configuration, there is no agent here. And then we put the label, and this gets deployed on this cluster, which is in pull mode. And we put a label on the other cluster, which is in push mode, and Sveltos will push the configuration to this cluster. So irrespective of whether your cluster is push mode or pull mode, the way we express what needs to be deployed, it's always the same. It's a cluster profile, or it's a profile if you're using profiles, because your management cluster, it's a multi-tenancy cluster. And same, it's going to be same also for events. The way you define what an event is, where to look for events, the configuration is always the same. The only things that changes is that if it's in push mode, Sveltos is pushing the configuration to the managed cluster. If it's in pull mode, Sveltos is preparing the configuration, what the agent needs to do in the management cluster, and then the agent comes, picks it up, and do the work. So that's what changes between the two modes. But this allows us pretty much this cluster, the API server is reachable, so I can directly push. This cluster is behind the firewall, so I cannot allow you to Sveltos to push here. And I'll just allow the agent to come and pick and take this configuration and deploy. This pull mode, it's also its implication from a security point of view, because if ideally, I know that it's kind of rare, but because the management cluster, very few admins have access to it. One is able like to break into the management cluster, essentially because there are the kubeconfig to access all the managed cluster in push mode. Ideally, pretty much like they can automatically break in all your cluster. If it's pull mode, there is nothing in the management cluster. So even if someone breaks into the management cluster, there's nothing that they can do to your managed cluster because there is nothing that, from the management cluster, there is no way to access the managed cluster because the flow is this way. This agent has very strict permission. So even if someone breaks into your managed cluster, which is in pull mode, there is nothing that this guy can do because you can only take the configuration that needs to be deployed. There is nothing else that he can do because this is works with our Kubernetes RBACs, and those are very strict. What is defined is very strict. This is same. So now this is again, it's a summary, and then we go like to the demo. When a cluster is registered in push mode, a Sveltos cluster instance is created in the management cluster, and we add labels to this cluster. And the labels are what are used by Sveltos to identify what type of application or nodes needs to be deployed on a cluster. When a cluster is also registered in push mode, a secret gets created in the management cluster containing the kubeconfig to access the managed cluster. And then the deployment flow is that Sveltos, anytime something needs to be deployed, takes the secrets, takes the kubeconfig, creates a client at runtime, and uses this client to deploy what needs to be deployed on that cluster. If we are in pull mode, a Sveltos cluster is always like registered in the management cluster because this is where we put a label. But this cluster is marked explicitly for pull mode, which means that there is no secret contains anything, kubeconfig, because there is no way to access this cluster. But also a service account gets created when this cluster gets registered. A service account gets created in the management cluster, and the service account is given very limited RBAC. And then user deploys this agent into the managed cluster. And from that point on, when something needs to be deployed in a managed cluster, which is in pull mode, the Sveltos components running in the management cluster prepares the instruction for the agent. The agent takes this instruction and does the work. Yes, so this is last slide. So we can go to the demo, unless there are questions.
No, doesn't look like there is any question. Maybe I have one question. So the agent, does it pull the Helm chart from the management cluster, or does it pull it from the internet?
No, it takes whatever needs to be deployed. No, it doesn't pull from the internet. Like it pulls it from the management cluster. The Sveltos component in the management cluster prepare the configuration that the agent needs to deploy. Because, for instance, you might want to deploy an Helm chart that it requires credentials. So you put the credentials just in the management cluster. So Sveltos does the templating of the Helm chart, and it takes the output of it, including the pre-hook, post-hook, and then instruct like the agent, this is what you have to deploy, which is a set of object needs to be deployed, including like all the hooks that needs to run. And then the agent knows how to process that and deploys the stuff. So it doesn't, all the configuration needs to be deployed comes from the management cluster. It's just that the Sveltos management cluster prepares like the configuration in a way that the agent can consume. And so the agent knows exactly what to deploy. Also because all the templating works exactly the same way. Sveltos can still reference resources which are in the management cluster and use those resources to instantiate the templates. And so the template instantiation happens before as part of Sveltos preparing the configuration for the agent. So when the agent comes, it just has to a list of things that he has to deploy or undeploy. He takes the stuff and deploy or undeploy. Of course, again, like when we're talking like about YAML, it's simply like applying those resources in the same order. When we talk about like Helm charts, it has a state machine to be able to process the pre-hook, post-hook, the upgrade and the rollback and the uninstall.
Super cool. Thank you, Gianluca.
So what I've done here, and hopefully the font it's good enough. Seems good to me. So I do have a GKE cluster where I have deployed Sveltos. Well, not all the components, because again, there is no official release with this feature yet. It will come soon. But you see that the add-on controller and the Sveltos cluster manager are here. Sorry, my bad. And this is a GKE cluster. And then what I have a kind cluster. So get bots. So I have this kind cluster, which it's nothing has been deployed yet. It's just like I create like a kind cluster. Clearly, Sveltos now is running on the GKE cluster, and the cluster that I want to manage is the kind cluster that I have locally. There's no way to manage this kind cluster from GKE with a push mod, because my kind API server it's pretty much not reachable except from my terminal. So the goal in this case is to register this cluster in pull mode. So the Sveltos kernel, did I copy the binary? Let me just copy the binary from the Sveltos kernel. So I can source it out. Sveltos kernel binary, Sveltos kernel. I'll just copy it here so I can run it from here. So now what I'm going to do, like I'm going to run like this Sveltos kernel command, and Sveltos kernel, if you're familiar with Sveltos, you know what it is. If you're not, it's just a CLI that comes with Sveltos, which allows you to, which simplifies your life when you are dealing with Sveltos. In this case, I added like so I extended the register cluster command. And once we register the cluster now, okay, this is not font, it's not ideal for this, but I added this pull mode option here. So when I use this command, what Sveltos is going to do is Sveltos is going to, if I run this Sveltos kernel register cluster in pull mode while pointing to the management cluster, what Sveltos is going to do is going to create a Sveltos cluster instance. It's going to create an account, a service account for the agent. It's going to provide the agent with the right permissions, and it's going to output what I need to post to the managed cluster for the agent to start and be able to work. So one more thing that I can show is that while pointing to my management cluster, there is no Sveltos cluster register yet. There is no instance of Sveltos cluster. So if I register cluster in pull mode, so okay. Say if I want to register a cluster and I want to put this cluster in the dev namespace and call it Gianluca, and I want to register this cluster in pull mode, and those are the labels that I want to add to this cluster. So if I run this command, it's going to output what I need to post to the managed cluster. So I'm sending the output to this file here. And what we can do actually before I run this command, I can verify that pretty much like can remove it. So there is nothing there. There is no, this file does not exist at this point. It's no such file. So if I run this command, again, I'm running this one while pointing to the management cluster. So run this command and crossing fingers because hopefully everything's going to work. So we can see what it's in this file, and then we can see what has been created like on the management cluster. So this file contains, we can do instead of a cut. So it contains what needs to be deployed into the managed cluster. So it's going to deploy this Sveltos applier, which is this deployment that I need. Before we deploy this one, we can go again to the managed cluster and we can see what has been created at this point. And we can see that there should be a Sveltos cluster in the namespace tab called Gianluca. It's not ready. There is no version yet because, again, we are in pull mode. So till we deploy the applier into the managed cluster, the agent to the managed cluster, there is, no way to know whether which version this cluster is running and whether this cluster is ready. This cluster is going to be ready only when the agent is deployed in the managed cluster and the agent is ready to deploy the configuration. So if I now I point to my management cluster, so I'm pointing to the client cluster. And again, just verify that this is the kind cluster. This kind kubectl config equals sorry. Called kind, it's kind kubectl if get ports. There is nothing running in the project Sveltos namespace. And now what I'm going to do, I'm going to apply the configuration that Sveltos gave me. Sorry. So this was the configuration that Sveltos gave me. When I registered the cluster in pull mode with the management cluster, Sveltos gave me this configuration. So I'm applying this configuration to the managed cluster. Once I apply the configuration to the managed cluster, now this agent is coming up, is being deployed. And as soon as this agent is up and running, if we go back to the management cluster and check the status of this Sveltos cluster, now I'm pointing to the management cluster. So now I can see that the cluster is ready, and this is the version of my kind cluster. This information was sent here by the agent that I just deployed. So the agent got deployed to the managed cluster. He has the necessary information to reach the management cluster, and it has permission to update this Sveltos cluster status. Its own Sveltos cluster status. So it took the version, it came up, it took the version that is running on the management cluster, on the managed cluster. It went to the management cluster and said, you know what? If you need to deploy something, I'm ready. And by the way, this is the version of the cluster where I'm being deployed. So now I prepared some configuration that I want to deploy. So we can look at this configuration here. So what I want to deploy, again, just one quick note. I think I showed it, but just to be sure, I added the label environment FE to this cluster when I registered. Right? That was part of this Sveltos cattle register cluster command. So now here I have this configuration here when I'm saying I want to deploy Caverno, this version here, 342, and with those, Helm values. And I also want to deploy some Caverno cluster policies, because pretty much, there is a depends on, because I cannot deploy Caverno policies till Caverno is deployed. So the Caverno CRD needs to be present on the cluster for the Caverno policy to be deployed. But this is an example where I'm deploying both an Helm chart and some YAML. The YAML is this Caverno cluster policy disallow like a stack. So if I post this configuration, and again, I'm posting this configuration pointing to the management cluster. Once I post this configuration to the management cluster, Sveltos components in the management cluster are going to detect that there is a cluster which is in pull mode, which it's a match for those configurations here. So they do prepare like a cluster summary, so that doesn't change. There is a cluster summary that indicates that something needs to be deployed. And of course, because of the dependency, Caverno gets deployed before the Caverno resources get deployed. But now, what is happening also behind the scene is that Sveltos is preparing, let's see if I'm fast enough, is preparing some internal resources that contains the configuration that needs to be deployed to the managed cluster. So when the agent detects those resources are created, the agent actually takes those resources and responds to those resources here. So we can wait for this to go to provision. So you already deployed Caverno. This is like Caverno was provisioned, so now we'll start deploying the resources. But meanwhile, we can just go now to the managed cluster, so kind kubeconfig. And what we can see is that, boom, Caverno got deployed there, like 20 seconds back. And there are 3 admission controller because we said we want 3 admission controller, 3 background controller, 3 cleanup, and 3 reports. And also at this point, let's see, it's also provisioned the YAML, which was the Caverno cluster policy. So again, if we point to the managed cluster and we look for cluster policy, this allow latest cluster policy is here, and it was deployed like by Sveltos 43 seconds ago. And now if we look for these resources here, those are all gone because essentially the agent, it came to the managed cluster, to the management cluster. It took whatever it was supposed to take. He applied to the managed cluster, and then in response, he comes back and say, I'm done. You can now remove the stuff because I acted on the stuff. So if there's something new, you create something new, but I acted on those ones, so you are free to remove those ones. So the configuration bundles resources that I showed before are just like a temporary resources that the Sveltos components, the management cluster, prepare for the agent to consume. And once the agent consumes, those resources are removed. I do have another configuration here that I want to show. This is this Nginx. The only reason I want to show this one, it's an Helm chart, so nothing different compared to what we deployed like in the step before. But the difference is this one, that in this case, I'm using like the continuous with drift detection, which means if something happens like to any of the resources that are deployed here, I want Sveltos to detect that one and react to it. So now, if I apply this one, again, I can just, pointing to my management cluster, I can apply this resource here. And we can wait, pointing to the managed cluster, we can wait for the Nginx deployment to show up. So he already deployed, like we deployed like the Nginx deployment at this point, 7 seconds back. So we can see that the cluster summary at this point should have been, it's marked as provision. So he also deployed this one. But now, what happens if now I take this deployment here and I delete it? I'm running in continuous with drift detection, which means that Sveltos, through the agent, deployed this component here, this resource here. But if something were to happen to this resource, I want Sveltos to override any change. So if I come here now and I delete this deployment, so I can do a delete of this deployment. Again, crossing fingers that this is going to work. Like the deployment at this point, it's gone. But what happens behind the scene is that the agent in the managed cluster detects that this resource, which Sveltos deployed, was removed. So now it has the permission to go back to the management cluster and say, you know what, you asked me to deploy something, which I did, but someone else overrode whatever we did. So it deleted, in this case, the Nginx deployment. And so the Nginx deployment is Sveltos on the management cluster says, don't worry about it. Like, I'll give you again the configuration that needs to apply. And the agent takes the configuration and applies it back. So the deployment now it's back. So even if you are in full mode, you can still do the continuous with drift detection. The agent is smart enough to detect any change and is smart enough to go to the control cluster and say, we need to deploy again because something happened. And Sveltos component management cluster prepares again the configuration for the agent, and the agent goes and deploys back, and the deployment comes back. Now, I also have a kubeconf. I also have prepared like a Sivo cluster and I use Sivo and Kind because those are super cheap. But you can take like any type of cluster. So this is a Sivo cluster where nothing else has been deployed, and I can register this cluster in push mode. So far we only have one cluster which is in pull mode, and we show that everything works, and we explained how the flow works. But I can also register, actually, before we go that one, I want to show one thing. This is the information that Sveltos use to know that the cluster is pull versus push. By default, it's push because pull mode by default is false. But we add like this field to this Sveltos cluster. So when a cluster gets registered in pull mode, this field is set to true. And this is how Sveltos knows. The agent, I can do whatever I have to do, but the agent on the managed cluster will take care of deploying resources. So now I can use the same register cluster command. I'm going to call this cluster Sivo. I'm going to say that this is not in pull mode. It's not going to output anything on the callback is the syntax to give the kubeconfig. Okay, it's kubeconfig with a hi. Equals hi. Sivo kubeconfig. So now, what I'm doing now with this command is, again, I'm pointing to the management cluster, and I'm registering this cluster Sivo in push mode. So we have an environment where from a GK cluster, we are managing a Kind cluster, which is registered in pull mode. And I'm registering yet another cluster, which is Sivo in push mode, because, like I can access the Sivo API server from my GK cluster. So I'll register this one. I should have at this point 2 clusters, Sveltos clusters, and this one, it's running Sivo, it's running this version. And in this case, what happened instead is that the one of the Sveltos components, which is running in the management cluster, because this is in push mode, it created a client, it used the kubeconfig to create a client to access the Sivo managed cluster and took the version from it. And so now that's how we know that this is running this version. And the Sveltos cluster controller in the management cluster is the one that set like this to true. I think we added the labels as well. We did add the labels environment functional verification. So when I go and look at the cluster summary now, I should have like 6 cluster summary. And those are going, some are going to Sivo, some are going to my Kind cluster, but all are provisioned, which means that in this moment, at this moment here, Sveltos running in the management cluster is managing one cluster which is in pull mode and one cluster which is in push mode. So you can use like a mixed scenario if that pretty much it's what you want, or you can pick just push mode, or you can just pick pull mode. It's up to you. Yeah, luckily even like the demo worked. So it's time for questions now.
Yeah, this is super exciting. Yeah, feel free to unmute yourself or use the chat to ask any questions. Yeah.
I've got a question. So when you were demoing this, you pointed out that there's no kube config to upload to the management cluster. And that, to me, strikes me as a really big benefit for day 2 operations, right? You won't have to rotate any secrets or anything like that. So it almost seems like there's a really big advantage to taking that approach operationally. Are there any downsides operationally to using pull mode over push mode?
No, there is no downside, but on the I want to add something on the even if you go like on push mode and you pass a kubeconfig, usually you're right that your kubeconfig is an expression. Like if you try to generate a kubeconfig versus a GK cluster, the kube config will be invalidated after 48 hours, I think, on GKE, or it may even be 24 hours if it's depending on the cloud provider. But Sveltos, even in push mode, can renew the kube config for you. So when you register a cluster in push mode, you can tell Sveltos, by the way, I gave you a kube config, which was created out of a token, which expires in 24 hours. So please, every 12 hours, go and renew the token. So you always have a valid token. So even in that case, Sveltos is going to do the work for you. You don't have to go and regenerate the kube config all the time and pass Sveltos the new kube config. It's I think documentation. So project Sveltos, just go there. GitHub. So you go to the documentation. There is a section on when you register a cluster. Register cluster, and yes, there is this automatic token renewal. So if you are registering a cluster in push mode, which means you pass Sveltos at kubeconfig, you can tell Sveltos, every hour renew the token. So renew the kubeconfig and create a token that lasts for 5 hours. So Sveltos is going to do it for you. So you just need to tell Sveltos, this is something that he has to do. So from that point of view, push and pull, it really, it doesn't make any difference from that point of view because Sveltos does anyhow the work for you, so you don't have to. I will say that the push mode, it's mainly if again, you want to manage your local kind cluster. It's one example, you're preparing something and you want to manage it, or think about if you are a company which is managing clusters for I don't know, finance or government, right? Government is never going to give you access to their cluster directly, right? Because they are firewall in front of it. Now, in that case, pretty much you can do in push mode. So you can still manage those clusters that are behind the firewall, and your management cluster doesn't have to sit in the same private network where those clusters are. Because especially if you are a third company managing those government clusters, you need to have your management cluster somewhere that is always accessible to you. But government, it's always behind firewall, so they don't want to give you access to those. So that's where I would use the push mode, the pull mode. Sorry.
All right. Any other questions? Curiosity?
One more thing that I want to add is that there will be feature parity. So it's not that picking one versus the other. You will have to renounce to something. Feature parity will be there. The agent and the Sveltos component, the management cluster, are going to be smart enough to make sure that, irrespective of which mode you pick, they're going to work. All features are going to work.
All right. So it looks like there's no further questions. Thanks a lot to everyone for joining the call. Thank you, Gianluca, for a great intro and demo. Oh, maybe there's one more question. I see Lamine. What is the difference between Sveltos, pull mode, and Rancher?
I know that Rancher Fleet has a pull mode, but I haven't used it. I would say that the difference is not the push-pull mode, but you have to look at all the other features that Sveltos offers. Look at all the templating, event-driven framework, tech support, all those features here. So you have to evaluate Sveltos for, if you want to do a comparison, I would say it's not just push and pull. but you have to look again at all the features, because it's not just about like pushing, saying what needs to be deployed. If you go here and you look at the number of features that Sveltos has, it has an extensive templating that allows essentially you just to create cluster policies which can potentially replace a controller. So you don't have to write a controller. You just like write the logic in Sveltos, and Sveltos does it for you. It has an event framework. It has a bunch of other features like, post-render patches, configuration drift, dependency management. It's multi-tenancy. So if you want to do a comparison between like Sveltos and Ranchers, I would say like take all those features and see if Ranchers have all those features. Again, I haven't used like Ranchers. I know that they have like the full mod, but I don't know what type of other features they have. And so if you want to do a comparison, look at the entire features set, not just a push versus pull.
All right. Anything else before we close the call? All right. So it looks like there's no other question. Thank you all again for joining. Thank you, Gianluca. Thank you for the people that ask questions. And yeah, we're always here. So feel free to reach out to us on Slack, GitHub, or I don't know, email, whatever. Thank you for all the applauses.
Thank you. Thank you so much.
And yes, yeah, we're gonna. I recorded it, so as soon as it's ready on the Google side of things, I'm gonna share the recording with all the attendees, and I'm gonna post it on Slack and everywhere, so everybody can find it.
And just one more thing: if there is no official release of Sveltos in pull mode, that is gonna still take like a couple of weeks because a lot of testing. Anytime we add something, we're going to do like we're doing a lot of testing to make sure we don't break anything. And again, our goal is feature parity, so it's taking a little longer. But I'm happy about the result because performance-wise is good, and everything seems to be working like perfectly. And so yeah, if you need this one, you may have to wait like a few more weeks.
No, it was actually pretty amazing how fast it was able to deploy stuff in your kind cluster all the way down to Italy, and God knows which kind of internet connection you have.